Thank you again for accepting our invitation.
Yeah,
Let
you're
me
welcome.
introduce you first to our audience. So, Gerd Gigerenzer is a renowned psychologist and a decision theorist, renowned for his work on heuristics, their applications in decision making, and how it applies to various domains and fields such as artificial intelligence or entrepreneurship. And he's also the director of the Center of Adaptive Behavior at the Max Planck Institute. Correct me if I'm wrong. Uh, just so we could begin, could you please explain the concept of heuristics and how they influence human decision-making processes, just for the audience that doesn't know you yet?
Yeah. So a heuristic is a simple rule that you use to make decisions. For instance, social heuristics. People tend to do what others do. They tend to buy the shoes that others buy. That's a very simple heuristic. It's called imitation. And you imitate the majority. You could also imitate the best one. That's different things. So a heuristic is a way to make decisions in a world of uncertainty, where you cannot calculate the best or optimal option or solution.
Yeah, right. And our audience mainly consists of founders and entrepreneurs. And one of the widely asked questions is, how can you ask, how can you learn in the context of entrepreneurship, where there's a lot of noise, there's also the survivorship bias problem and the small sample sizes. So there's lots of thinkers and doers who write articles who discuss various topics, but the interesting question is, how do you know what to believe in, how to guide yourself?
Now, in a world of uncertainty, often called VUCA, so volatility, yeah, uncertainty, complex, and ambiguous, in this world, you cannot optimize. That means you cannot find the best solution. Business schools, nevertheless, still teach
Yeah.
expected utility maximization, which is a form of optimization, as the way you should make decisions. But then you leave business school, you're in the real world, and you see it doesn't work. And
Yeah.
the alternative is a more modest view about our human capabilities, so that we, even if we cannot find or know the best solution for the future, we can do something that is good, that is better than what that other kind of strategy decisions. So a simple example is the following. Remember, Harry Markowitz, the economist, got his Nobel Memorial Prize for solving the problem how to invest your money into N assets. And the method is known as the mean variance portfolio. So this is not a heuristic. This method assumes that you can actually estimate all the future returns of each of these assets, their variance and their covariances. When Harry Markowitz made his own investment for the time of his retirement, then he used his Nobel Prize winning optimization method. So we might think, but no, he didn't. He used a simple heuristic, which is called 1 over n. It means you have n assets and you allocate your money equally over this n. So if it's just 2 assets, you do 50-50, 3, a third, and third. This is a heuristic. Now you can ask the important question. Can we identify the situations where the optimization model or the heuristic will make more money, say, according to Sharpe ratio or other criteria? And this is the important question. I call this the question of ecological rationality. The rationality is not about consistency. inside a mind, but about the success in the world. So can we identify the conditions where 1 over n will outperform the Nobel Prize winning portfolio and vice versa? That's the relevant question. So if you think a moment, if the n, the number of assets, is very large, then Markowitz optimization has to make many, many estimates and will occur lots of estimation error. So that's not the world where will be perform well. And if it's smaller, then it may do better. And that can be shown. For instance, in one study, there were 8 investment problems tested, and in 7 out of the 8, 1 over n outperformed the optimization model. Now, how can a heuristic outperform optimization? That's the question. Now, the answer is very simple, because you can't optimize in an uncertain world, and all the optimizations, what it does, it estimates parameters from the data from the past.
Yes.
But if the future is not like the past, then heuristics bet on robustness. So 1 over n assumes I really can't predict it, so I keep it, I do perfect diversification.
Right.
And this is an example about heuristics versus optimization models.
So in certain cases, heuristics can outperform optimization models,
Yeah.
mostly in the areas of uncertainty and where you cannot rely on the past data.
Yeah, I would say if you have a stable world where nothing new ever happens, then you can fine tune on the past data, and you will do better than heuristic methods. I mean, better in accuracy. Heuristics are always faster and allow immediate decision. But
Right.
the more uncertainty there is, the better you're advised, make it simple and robust.
So in your papers, you discuss the distinction between stable and ill-defined problems, especially in the context of algorithms.
Yeah.
Can we delve deeper into this distinction?
Yes. Mm-hmm. So a similar regularity holds when we talk about AI. And let's now talk about the kind of AI which are deep neural networks. So these are basically regression models or discrimination models, only recursive and much more powerful. These models need to estimate the parameters. Again, that's why you need lots of data. And data is only useful, or the data is the more useful if the future is like the past. So if you have a stable world where nothing new ever can happen, like chess and Go and other games or industry applications, then this type of AI will be excellent. That is the world, well-defined, stable. If that's not the case, then it no longer holds. So the currently, or already since years, AI is used to predict human behavior, like in recidivism prediction or predictive policing. And in these cases, we know that very simple heuristics that just look, say, at the age or previous convictions cannot be outperformed by the best AI models. Why? It's not like chess and Go. It is highly uncertain. Human behavior, humans are the major source of uncertainty.
Yes.
And the advantage of heuristics then is that they're transparent, that you can actually see what it's in it, and you can see whether there is discrimination, which is difficult in black box models.
And in these cases, can heuristics be applied, let's say, to AI? Can AI benefit from somehow from heuristics, maybe from incorporating heuristics into the models?
Yeah, this is one of my claims, that under uncertainty, uh, the study of the human mind is a heuristic machine. So humans evolved to deal with uncertainty of weather, of the conditions of the earth, of animals or other humans. Well, one constantly needs to adjust to different situations and make guesses about what the other wants. And in these situations, humans have developed a number of smart heuristics. And when one develops programs about, say, predicting future uncertain events, then one might look how humans are doing it and modeling these heuristics and to make computers smart. This is the old version of AI, one that goes back to Herbert Simon. Herbert Simon is one of the founders of AI. His vision was to study expertise and program these heuristics that they use, the experts, in order to make computers smart. The success of machine learning has made many machine learner researchers think that you can totally ignore the human mind. You can't learn anything. You just do your calculations. And that may be true if it's a situation of chess and Go and industry applications, to some degree at least. But it would be an error in if one deals with uncertainty. So I can give you an example. So think about predicting the flu or the coronavirus. So these are two viruses don't behave in a well-defined way, as we have seen in the last years. They're very hard to predict. So remember that the Google engineers tried to predict the flu between 2008 and 2015. And precisely the proportion of flu-related doctor visits in each of those. And the idea was that one can predict what is happening now. Was called nowcast. So and the idea was smart. We just look what search terms people enter, and then we can use the search terms in an algorithm and find out where the flu is going. This was a big data algorithm. With the first version had about 45 or so variables, all secret, as Google does it most of the time. And so a black box model. So it started in 2008, and they had done everything right. They had done cross-validation and so on. But they were not in a world of out-of-sample prediction or cross-validation, which is stable. But in 2009, something unexpected happened, the swine flu. It came out of the season in the summer. The algorithm had learned from big data that the flu is high in the winter, low in the summer, high in the winter, low in the summer. So it predicted low when the swine flu hit, and it couldn't change. Like a big truck can't change very quickly. So then the Google engineers revised the algorithm because it didn't work. They couldn't get it there. Now, what would you do if you have a complex algorithm and a complex problem and your algorithm doesn't work? Do you make it more complex? or simpler? That's the question. According to our research, what you need to do is make it simpler. That's the secret of heuristics, so that they get robust. The Google engineers did the opposite. They made it more complex. Then they had about 160 variables. It didn't help. And there were 3 more updates of that. So we did a test. So some of my own machine learning people and I, we are developing what we call psychological AI. So that means you study how the evolved brain deals with a certain situation, and then you program an algorithm so to make algorithms smart. That's so. How does the human mind deal with situation where the future is changed in an unexpected way? We know this already from memory research. We forget. We forget very quickly, and in this situation, even quicker. And in the extreme, we only use the latest data point. And that's what we formalized and put it in an algorithm. It's called the recency heuristic. The recency heuristic just looks for the latest data point and predicts and ignores all the rest. And the prediction is the next one will just be the same. Very simple. No free parameters. And you can understand it. Yeah? So in the case of the flu, the algorithm says it takes the last data point, say from the Center for the CDC, Center for Disease Control, which is usually 1 to 2 weeks back, and makes a prediction. The nowcast, so this week, is the same. Very clear. No secrets, no black algorithms, no big calculations, and no big data. And you can now understand that when this swine flu happens, for instance, the recency algorithm, they gets it wrong once, but it can adjust immediately because it ignores the big data. Google's flu trend algorithm could not ignore because it's based on big data. See that? And so we tested it for the entire years from 2008 to 2015. And in every year, the simple recency heuristic predicted the flu-related doctor visits better than big data, Google, and also for all of the 4 updates. So here's an example, a simple heuristic informed by human psychology can actually outpredict a big data model. So the typical reaction I get, yeah, then we build a more bigger model. That's exactly the problem. No, no, you should respect the human mind and first ask, can we learn something from the human mind? And it may be the answer is no. But in many cases, you can learn something and you gain a much less costly algorithm that needs less energy, that is transparent, you can explain it, and you can also see how it works and how to improve it.
Now, if we look back and see what's happening now, it seems that the Google engineers and all the big players in this industry that are developing large language models or self-driving car startups haven't learned the lesson from the past,
Yeah.
and they're mostly neglecting this perspective on AI. Why do you think that's the case? If they have the financial resources and if they're financially motivated, wouldn't it be cheaper and better to test AI models informed by psychological heuristics and see if they outperform or not the large models in general?
No, that's a good question. Yeah? And there are several answers. One, there's the complexity illusion. The idea that with more data and more data and more data and more complex algorithms, you could do predict better. This is true in a stable, well-defined world, but it's not true in an uncertain world. And this insight, the entire thinking about that the performance of algorithms is conditional on an environment, is not well developed. People argue that this is the best algorithm or this is the best. There's no algorithm that's the best. And
Yes.
so that's one of the problems. And then also we have a kind of, even among psychologists, there's a tendency to look down to the human mind, at least to those of others. And you can see this in the so-called biases literature, in behavioral economics, where, for instance, the same heuristic, recency heuristic, is listed as a source of irrationality. They've never tested that. They know that it's irrational. If you just look at the most recent thing and forget the rest, it must be wrong. So it also means that psychologists can learn about to think in an ecological way.
So you're saying that the main reason is that people just believe that we have nothing to learn from the human brain, and
That's
the
one thing, and even look down.
yeah.
Yeah, yeah. And there are more reasons. Let's go back to Harry Markowitz. And here you have the mean variance model, who got a Nobel Prize. And
Yes.
here you have a heuristic 1 over n that outperforms, in many situations, the Nobel Prize. Now, let me ask, would Harry Markowitz had gotten a Nobel Prize for 1 over n?
No.
No. With the same complexity illusion. If something is complex, it is likely good. If something is simple, it can't be good.
Yes. The situation seems very similar to what Nassim Taleb did in finance.
Yeah.
His insights were mainly and they're still overlooked by the major business schools, and people tend to ignore them, even
Yeah.
though they've largely outperformed the financial models. And also another thing about the large language models, now that we have them, people are generating content at scale. So blog posts, books, essays generated by AI. So at some point, the AI will have to learn trained on the data generated by AI in the past.
Yeah. Mm-hmm.
It's interesting loop.
And in the very extreme, we'll just take all humans out of the loop. Why do we need us? So there are even quite a number of my colleagues, when they write articles or proposals for funding, they use ChatGPT or another large language model.
Right.
And I would want to know how many reviewers use ChatGPT to review the papers being written in part by ChatGPT. So that's the one thing. But more seriously, we have now a situation where papers are produced by AI, fake papers, by so-called paper mills. This is an industry-like business of producing fake papers with the help of AI. And particularly in medicine, in the experimental part of medicine, not so much in randomized trials, estimates are that maybe already 10% or more of all papers published are fakes. Why would this happen? Now, for instance, the Beijing authorities have a rule. If you're a doctor in a hospital and want to move up in the hierarchy, you have to have 2 first authors papers that are listed in a respectable journal, defined as a social science index. And many doctors have no time or don't know how to do research. So there's an easy way. They ask a scientific assistance company who allegedly helps them writing the paper, but in fact writes the entire paper. and they pay between 10,000 or 20,000 US dollar equivalent. And then if they pay 25,000, they get a paper published guaranteed. That's a business. And we know that a friend of mine is an editor of a medical journal, and he got from a paper mill an offer for every paper he published in his journal. He gets $1,000 multiplied by the impact factor. That's big business. And so this is a very dangerous way to undermine science by commerce.
Yes. If we talk about the algorithms, such as deep neural networks, do you think that neural networks have, in general, the capacity to at least mimic understanding instead of just being advanced statistical machines?
They are advanced statistical machines, period. They don't understand in the human sense.
Yes.
They are not intelligent in the human sense. They're in a different way. And you can see this very, very clearly with image categorization. So there's a number of pictures, and then the trained neural network can tell, say, a school bus from a regular car, and so on. And the way you see the difference is by the errors humans make versus deep neural networks make, and they're very different. And I have a few pictures in my book, How to Stay Smart in a Smart World, where, for instance, there's a school bus, an American school bus, which is yellow-orange and with a black frame. And if you use adversarial algorithms that find out where the weak points are of the deep neural network, one can construct images that a deep neural network that is well trained and knows all the buses can identify in the training and the test set is being misled. One of these pictures is one where there are just stripes. There's a yellow stripe, a black stripe, a yellow stripe, a black stripe, and the deep neural network thinks it's a school bus. No human would commit this error. Humans commit different errors. So if you put lots of random noise over a picture, then deep neural networks do better in guessing. But if you do systematically changing a few pixels, like with the help of adversarial algorithms, then these changes, they swamp neural networks, but not us. So that's an important thing to realize. And also, the studies have shown that even if the performance in classification of humans and deep neural networks are the same, the processes are not the same. And you can see this because the major experimental facts in vision, you don't find them in deep neural networks. But there's still the belief that if something produces something like with ChatGPT, a very nice text or a poem, then it would do this in the same way as humans. No, it's a different intelligence. And it makes very different, you can fool them.
Yes, even at this point, the best generative AI startups, they still have trouble with generating text on images.
Yeah.
So that's an interesting observation. And in decision theory in general, what's the distinction between risk and uncertainty?
Yeah.
And how does it, relate to AI and the stable world principle?
Yeah. I think, so the distinction between risk and uncertainty is this one. In a world of risk, you know everything that can happen, all the consequences and all the probability distributions. So, example, you go this evening to play the roulette in a casino, and you know everything that can happen, a number between 0 and 36, nothing else. All the consequences, the money you get, and the probabilities. This is a world of risk. A world of risk is something that's really boring. Because as Fyodor Dostoevsky had once said, if everyone would be rational, nothing would happen. So no good novels, no love affairs, nothing. But that's a world of risk. And most of decision theory just deals with this world of risk. So expected utility maximization is defined on a world of risk, not on a world of uncertainty. And for instance, Jimmy Savage, who is called the father of Bayesian decision theory, was very clear about this restriction. He said it would be ridiculous to apply expected utility theory to, say, planning a picnic, because unforeseen events can happen. In Berlin, where I live, we just, a few years we had ago, an unforeseen event that made around the world. This was a photo of a man picnicking, nude, as it's normal in Berlin. And then something unexpected happened. A wild boar came with 2 piglets and picked up his yellow bag, including his laptop, and ran away. Just as an example.
That's some serendipity there, right?
Yeah. And the other thing is uncertainty. And that's the world of heuristics. And here, those who just are in love with the mathematical theory of behind maximization, they just don't want to deal with that. And this is most of economics, most of decision theory, and a large part of psychology. It's the old dream. I want to have one algorithm, like one God, who tells me how to decide. The moment you are in a world of uncertainty and accept it, and you have heuristics, you don't have one, you have more. So Markowitz 1 over n doesn't help you in many situations. It helps for allocations. And imitation doesn't help you if there's no one around, like Robinson Crusoe. And so you need to think about, you need judgment about when to use what. And judgment hasn't been part of the small world of risks. So here we have very interesting phenomena, but we can learn, as you said. In the world of uncertainty, usually there are less is more effects. To a certain point, more information doesn't help, it hurts. And you need to bet on robustness, not on optimization, because optimizing in a uncertain world makes the system fragile. And we have seen this in the in many financial breakdowns. And I mean, finance is the type of Merton finance, who works wonderful in a stable world. But if something unexpected happens, then it breaks down. And it needs to be rescued by taxpayers' money.
Yeah, that's what Mandelbrot called wild randomness, case of finance.
Yeah.
It's interesting that the problems seem to stem from the academia, because again, most startups or most it's really an overlooked insight that most startups working in generative AI, you don't really use insights from psychological theories and decision-making theories.
Yeah. Yeah, it's a good point. So on one side, many problems we have stem from that part of academia that only makes models about risk or stable worlds and ignores the rest, or even confuses uncertainty with risk. You can see this all the time. And the other problem is that machine learning people who know that their most problems are intractable, that you can't use expected utility maximus or anything like that, they know that part, but then they forget about the psychology and think that all that is irrelevant. Or at best, we might think whether a self-driving car can build in morality, so that he may do what you think, when he has to choose between kill the driver or kill a pedestrian, or maybe two pedestrians against one driver, or maybe young ones or old ones. This is the part where then psychology comes in, but only after the fact. And anyhow, we have no self-driving cars on our roads. And that's another case where, so my bet is, I think that this traffic, so regular traffic, is much difficult and too uncertain. Yeah. And for the so-called level 5 cars, so a self-driving car is defined as a level 5 car. That means a car that can drive safely without a human backup and under all conditions. There's nothing like that. But Elon Musk tells us every year that's around the corner. He's told us since 10 years it's around the corner, maybe. Okay. And what will happen if we continue bet on cars is something much more interesting. It's called level 4 cars. A level 4 car is defined as a car that can drive without human backup, but not everywhere. And in order to exploit the limits of the technology, what will happen is we have to redesign our cities. So putting walls around streets, or fences at least, so that these level 4 cars can drive safely and forbid humans to be on the steering wheel. So human drivers will no longer allowed, at least in that part of the street, because they create the uncertainty. And this is a much more, I think, interesting look at AI. Not that it gives us another gimmick like a self-driving car where you can lean back and do whatever you want, but it changes us.
So we'll have to adapt the infrastructure to enable.
We need to have an infrastructure that is more stable, and also we humans need to become more predictable. The AI can deal with predictable humans, not with us as we are now.
What if we'll see an increase in the share of, let's say, self-driving cars as they are now, like in San Francisco with the self-driving car startups with taxis? Do you think will be a huge accidents, a huge in the future?
I mean, the most of the cars that are called self-driving cars are no level 5 cars.
Yes.
So the famous accident with the lady that has been killed, this was a human driver on the car. She didn't pay attention. And that's the next problem. The idea to have, so level 3 cars is the idea to have a car that we have level 2 cars, should say. So this is level 1 car is a car that can do one thing, like keep distance from the next car. We have this since 50 years or so. Level 2, what we have now, they can do multiple things and integrate them, like automatic parking. Level 3 would be a car that can do everything but still needs a human backup driver there if something goes wrong. And that's not the solution, because if you sit there 2 hours on your behind the wheel and wait that something goes wrong, nothing goes wrong, then you don't pay attention anymore. And if something goes wrong, you would have to react in a second, and you will not be able to do it. So that's also not the future. And adaptation to the limited possibility of AI, that will be our future if we want that. But we also could develop a better public transport system that would be the European alternative. It's well known that Elon Musk hates public transport. That's one of the reasons why he makes all these outrageous claims about self-driving cars to impress politicians, so that they think, oh, public transport is anyhow something of the past. We don't need it.
And also one of the reasons why he keeps making these claims is perhaps to just keep his shares high.
Yeah.
Many people are betting on this outcome.
Mhm.
That's why they keep investing in and hold their shares.
Yeah, it's an attention economy. Huh? You just make more and more outrageous claims and you get all the attention. And he's certainly a risk taker. There's no question about that. But also potentially dangerous figure. That's the other side, because we are getting into a society where the power is concentrated in a handful. It's almost always men, immensely rich, that have sometimes quite strange visions and control us.
Yes. And also, if we start using AI algorithms in high stakes decision, again, as you mentioned previously, if we don't have any transparency, it will be
Yeah,
a very interesting future.
yeah. No, I think that all sensitive algorithms need to be revealed to the public. That is, I've been serving on the advisory committee for the German government, on the Ministry for Law and Consumer Protection. We've made these proposals. And many things could be changed so to get the power back to the people. But it also needs an education. And for instance, one of the problems is the pay with your data system. And most people enjoy that. They don't have to pay and they don't realize what they're paying. So to understand the situation in when you're on Facebook or Instagram or something similar is, here's a way to understand this. Assume there's a coffee house in your city and it offers free coffee. Free coffee. So you go there and meet your friends. Everyone is happy except the other coffee houses who get bankrupt. But still, you don't have to pay and enjoy your time, but you also have no choice anymore. And when you sit and chat with friends, the tables are packed and the walls are with video cameras, and every word you say is recorded and analyzed, and also with whom you talk. And the coffee house is full with sales people who constantly interrupt you to offer you their personal products. That's about the situation when you're on a social media. And the important thing is, in this coffee house, you are not the customer. The customer are the sales force. You are the product. Your attention, your time, and your money. And it's important to understand this. And that example also shows what the alternative would be. Namely, that we need to have the right to pay for our own coffee, to get rid of the sales force and become the customer again. And then the question is, how much would this cost us? And in my book, How to Stay Smart in a Smart World, I have made a calculation for that, and I just summarize that here. So for the Meta company, so that owns Facebook and Instagram and WhatsApp and many other things, in order to reimburse them for their entire revenues, so that they would win, the profit would be actually then bigger because they don't have to spy on us anymore. So to reimburse them on the entire revenue, per month, every user would have to pay about 2 euros. That's a coffee. So it would work, but we would need governments who understand that and are willing to find a legal solution. And we will need people who understand the situation in which they are in and are willing to pay. The problem is that only few people understand it and are willing to pay. I did a survey in Germany, and we asked, assume you could get that personal data about you, so would no longer be subtracted. So whether you're depressive, whether you're pregnant, or have a heart disease or anything else that can be misused by, and is actually then being misused by whoever is interested in that, it's no longer done. So how much would you pay? 75% of Germans say, I'm not willing to pay a single cent. So we don't have the people who understand that they're actually sleepwalking into surveillance.
It's the same case with YouTube. YouTube now offers a priced a premium plan when you don't have any ads, and
Yeah,
people are reluctant to buy it. Actually, I think that recently Meta announced that they'll launch a subscription in Europe to avoid any ads and
yeah,
personal data.
yeah,
The price would be about 9.99 euros per month for Facebook and
yeah,
Instagram.
yeah.
So it's higher than your figures in your book.
Yeah, because they want to make sales.
They don't want to make sales. They want to prove that nobody will buy it. So essentially,
Okay, yeah, yeah,
either you allow us to stay in, or we just go.
yeah.
And you have no WhatsApp, no Instagram, no Facebook.
And if, for instance, many people don't see the problems behind that. We know today that many teenagers more or less are addicted, and also adults. They check all the time. This is a psychological mechanism that's very similar to gambling addiction. It's called intermittent reinforcement. You don't always get a like, and that's the point where you constantly get checking whether there is something, maybe a heart or a comment or something. And you get similar phenomena like in addictions, or a gambler who sits on the machine for 2 hours can rarely remember what happened during these 2 hours. And many who scroll and scroll and scroll and scroll, after an hour, they can't even remember what there was. So this is an automatic behavior that is directed by what's called intermittent reinforcement. So the point that you are looking, there could be something, but there's only sometimes something, and therefore you look all the time. The psychologist B.F. Skinner has shown this with pigeons and rats. And if you don't give them food, say 3 times a day, that wouldn't be intermittent reinforcement. So they get excited around the time when it comes. But you give them food randomly over time, then they're excited all the day, and they pick and pick and pick and pick. And the same thing is done with us. We check, and studies show that if a smartphone is just next to people and shut down, it's still their performance is worse than if the smartphone is in a different room. It detracts attention.
Right. So that's, again, that's an interesting thing. We'll have to see what happens in the future. But as you mentioned, people don't really care about their privacy any longer.
Yeah, that's changing, right?
You're not willing to pay the price of a coffee for, yeah.
Yeah.
And can you share your thoughts on genetic intelligence? You know,
On
the
general,
genetic intelligence.
genetic intelligence.
Yes, and if are we ever going to be able to mimic at least the genetic intelligence with AI in the future, maybe?
So you mean genetic intelligence in humans?
Yes.
Yeah. Okay. No, the point is that it's very clear that human intelligence is a function of nature and nurture. Yeah. So if you don't have the genes, you don't get it. But it also needs some training and expertise.
Yes.
Mm. And human intelligence is not, in my view, an IQ point. That, but it's a bundle of heuristics that people use to deal with other people, with problems, or in management, with personnel, or with strategy. And these, you can find sometimes a similar type of heuristics, like imitation in many animals. They learn to do, and this is the vehicle of culture, they learn to do what others do, but it's much more unsystematic and not general. So, and the very point is that we do not really well understand both human intelligence and also the genetic base of human intelligence. If you would understand that, we could probably make human intelligence. And then
Well,
they, yeah,
someone from our audience, again, it's more of a science fiction, but he was thinking about what if we will ever be able to make AI come up with heuristics and be able to make it similar to the human brain and
yeah.
make some kind of model that will learn from experience and try different things and
Yes, I think this is an important way AI can go. You know, machine learning amplified
yes,
by insights from the human mind. Yes, that's very important. And here I see a future. And I've given you a few examples. And the that's certainly one thing. And equally important it is to we talk about the positive sides and the negative sides of AI. And I think that's the wrong question. We should talk about so AI is not a danger or the big hope. We have to look at the people behind AI.
right,
It's a Zuckerberg, it's a Musk, it's a Putin, it's a Xi. It is the people who use it. And the moral questions are not about AI. AI is not moral. It's a statistical, if you think about deep neural network, it's a statistical machine that is not moral. But the people behind it who use it in drones or in other applications, that's the real question we should talk about.
yes, yeah, that's certainly interesting, especially with if you look at the people, as you mentioned, who are behind the wheel, so to speak, in this case,
Yeah,
mostly highly influential, powerful, and men with unclear motivations.
yeah,
And
and quite a few among them seem to be border on the autistic spectrum. That's also interesting. So the nerds take over.
and one last thing before we end the interview, are you planning to work on more books about AI and psychological AI in the future? Are there any works you're involved in today that might be interesting to our audience?
Um, I have just published a book, a new book one, just out of a few weeks, on a related topic. It's intuition. AI has not yet intuition. It's called The Intelligence of Intuition. It's Cambridge University Press, The Intelligence of Intuition, and it tells part of the story that we talked about. So the war against intuition, downplay it. Calculation is better. Oh, that's the typical view. And on the other hand, if you could get intuition into AI, that would be a real progress. So if that's of interest, it's called The Intelligence of Intuition. And I'm also working on psychological AI. So what are the human capabilities that we can use and program in order to make, say, better predictions?
Yes. Okay. Thank you. I think we're done because the hour is over. Thank you for accepting our invitation. It was certainly an insightful discussion,
Yeah, it
and
was a pleasure. And keep thinking. That's the most important thing in a technological world.
maybe
The danger is not in AI. The danger is in us dumping down and leaning back. That's a real danger. If companies, if refrigerators and cars get smart and smarter, we need to get smarter.
somebody from our audience at some point in the future will manage to raise funds for a research-driven startup, and will use your insights
Good.
in model development. That will be a really great thing.
And let me know when you're
Yeah.
there. Okay.
Thank you.
It was a pleasure. Bye bye.
Have a nice day.